Okay, here we go, boys and girls. This is assignment 3K worksheet. This is our first review of this lesson. And what we're asked to do is find or compute just a bunch of derivatives. And these are going to be fractions and roots and things like that. So skills that you have to be really comfortable with. Okay, skills that you have to be really comfortable with are the skill of rewriting. So for instance, noticing that a third root is going to be in essence to the third power. Okay, a denominator of a square root or something is to a negative 1/2. Those sort of things. You have to be really familiar with those. Also, you're going to need to be comfortable with the chain rule. So in essence, peeling that onion of derivatives. So start at the outside and start working in and in and in. Okay, and last but not least, the one thing that I kind of want to mention to you is when you get an answer, clean it up somewhat and just kind of do your best with the cleanup process. Just note that if you were to be doing like a multiple choice question, your answer that you get may look completely different than what the answer that is actually correct. I'm not saying that you're wrong, but there's a cleanup process and sometimes it gets pretty involved. So just keep that in mind. All right, so problem number 1. Before I actually do this problem, I am going to rewrite it. So I don't like square roots, I don't like third roots and things like that in my problems, so I eliminate them through the use of exponents. All right, so now I can see my chain rule much easier. So when I do my chain rule, the first thing that I'm going to address is this outside power to the 1/2. So again, with the chain rule, you do the derivative of that. Okay, you do the derivative of the outside, and you leave the inside completely alone. You don't touch it. Okay, and then you multiply, and now you deal with the inside layer of the onion. In this case, that would be the 1 plus 4x squared. So take the derivative of that. So 1 goes away. 4x squared is 8x. All right, so the cleanup process is going to make this 4x, and then 1 plus 4x squared to the negative 1/2. Okay, I am absolutely pleased as punch with this answer right here. Now, here's the last bit that I was mentioning before. If you see this problem, or if you see this on an answer key, this absolutely is not going to be the answer. What they're going to do is they're going to try to turn these things into roots and denominators where applicable. So they'll turn it back into kind of like math writing kind of stuff. And so what you would see is this. The 4x is a numerator, and then I have a denominator of this square root. So this is going to be 1 plus 4x as a square root in the denominator. So that's what it would look like on the answer key itself. Oh, sorry, 4x squared. Sorry, 4x squared. That's what it would look like. Okay, moving forward to number 2. Number 2, I can get right to the derivative here. The outside layer is this to the 2/3 power. So again, I take care of that. Leave the inside alone. Reduce that by 1. So 2/3 minus 1 is negative 1/3. And then here comes the chain rule. So 5 goes away. Negative 3x is negative 3. So the cleanup process, 2/3 times negative 3 is just negative 2. Again, I'm pretty pleased with that answer. However, it is not going to be the answer that you would find on an answer key. This one would be a denominator of 5 minus 3x inside of a third root, all underneath negative 2. It'd be something along those lines. All right, let's go ahead and rewrite this gy right here. So I have a square root in the denominator, so this is going to be 25 minus y squared. Okay, so it's a square root, that means it's a 1/2 in the denominator, so it's a negative 1/2. So taking my derivative, the first thing that I need to address is this outside to the negative 1/2. So I take the derivative of that. So that's going to be negative 1/2. Leave the inside alone. Minus 1 would make that negative 3/2 times the derivative of the inside, which is a negative 2y. So 25 goes away. Negative y squared is a negative 2y. Take it to the cleanup process. So negative 1/2 and negative 2y leaves just a singular y. And then I have 25 minus y squared, negative 3/2. Then I'm cool with that answer. I like that. However, you're never going to find that. So what that would look like is a lot of times when you get like bigger fractional exponents, like to a 3/2, they'll leave it as a fractional exponent, but they'll put it where it's supposed to be. Rarely, rarely, rarely will you ever see an exponent keeping the negative. Rarely, you'll see the 3/2, but you won't see the negative. So what this would look like is this would be, we're going here, 25 minus y squared to the 3/2, and that negative makes it a denominator, and that y would remain on top. So you'll sometimes see, proper fractions, or I guess that'd be improper fractions still hanging around. But if you see like to a 1/3 or to a 1/2, they'll convert those to the roots. But if you have like a root to a power, you probably won't see it written as a root to a power. You'll see it as like 3/2 or something. All right, number 4. Number 4 is still a chain rule. So the outside, actually, let me rewrite it one time. This is going to be 2 cosine t to the 1/2. So the outside portion of this chain rule is this 2 cosine. All right, focusing on that cosine, this is going to be the derivative. Cosine goes to negative sine, so this is going to be negative 2 sine. Leave the inside alone. All right, so that's the derivative of that. Now the chain rule is the inside, that's the t to the 1/2, and that's going to be 1/2 t to the negative 1/2. So what will this look like? Or let's do one of our own cleanup steps, and that is in essence taking the negative 2 and the 1/2 t squared. So this is going to be negative t to the negative 1/2 sine t to the 1/2. Okay, so again, I'm pretty decent with that. Again, you're never ever going to see that as far as an answer key is concerned. So, so what this would look like is this: a negative sine square root t all over, and then the first t is a denominator root t. So it would look something like that. All right, now when we get to these kind of problems, the cleanup process would be way more difficult. Okay, so I'm going to first convert this into a method that I kind of understand. So I see that this is a big square root, so this is all to the 1/2. So I'm going to attach those things and avoid the quotient rule. So this g of x is, I have a numerator of 2x minus 5, and that's going to get a 1/2. And I have a denominator of 3x plus 1. That gets a 1/2, but because it's a denominator, it'll be a negative 1/2. It'll be a negative 1/2. All right, so here I'm going to have to do two things. I'm going to have to do the product rule, because this is a u and this is a v, and they're multiplied. All right, so when I do the product rule and I get a u prime v plus a v prime u, when I do this, like for instance, this u prime, okay, this u prime, notice that that would have to still include the chain rule. That's still going to have to include the chain rule. Kind of idea. Okay, that's the u prime. The u prime, the chain rule is involved with just the derivative itself. All right, so don't forget about the chain rule, even though you are simultaneously using the product rule. All right, so we are going to be taking this derivative, and so I'm going to go u prime. So this is the 2x minus 5 business. So the u prime, I have to do the chain rule. So that's u prime right there, u prime, v, which means I just leave this 3x plus 1 to the negative 1/2 alone. So that's u prime v plus v prime. Okay, so the v prime is going to be the derivative of that second bit. So that's the 3x plus 1 portion. And so that's going to be negative 1/2 to the negative 3 over 2 times 3. So don't forget the chain rule on that. So that's v prime. Now I have to add the u to that, which is just the regular 2x minus 5 to the 1/2. So again, let me write this in purple, what I just did. This is u prime. This is v plus. This is v prime, and that's u. So I did the product rule, but the product rule had to involve the chain rule when I took the derivative of u and the derivative of v. Okay, cleanup process. Googly moogly. All right, so things to the outside. Let's just start there. Things to the outsides, I have a 1/2 and a 2, so that's a 1. So I have a 2x minus 5 to the negative 1/2, and I have a 3x plus 1 to the negative 1/2. So I have that. In the second portion, it's not a plus. It's going to be a minus because I have a negative 1/2. So I have a negative 1/2 and a 3, so that's going to be a minus 3 over 2. And then I have a 3x plus 1 to the negative 3 over 2, and a 2x minus 5 to the 1/2. Okay. I'm okay with that. I'm okay with that, I guess. I mean, it's obviously still a nasty looking answer. But let's go down the rabbit hole of the cleanup process. Okay, if I were a mean teacher and asking you to clean this up, what would that look like? Give me 1 second here. What would that look like? Okay, so let's just put things in proper places. So we have a 2x minus 5 on the bottom. We have a 3x plus 1 on the bottom. Over here we have a 2 on bottom, a 3 on top. We have a 3x plus 1 to the 3 over 2 on bottom. So I'm going to write it as a square root here real quick. Just temporarily, I'm going to write this as a square root. to the third power. Right? Just temporarily. And then I have a square root of a 2x minus 5 on top. Now, the key to a successful cleanup process is just getting a common denominator. So we're left with the subtraction, and we need to obtain a common denominator. And that's usually the key to success and what you physically need to be doing. All right, so taking a look at the easy stuff. What does the left-hand side need that the right-hand side has as far as the denominator? Well, it has a 2, so I need to put a 2 on the left-hand side. It has a square root of 3 plus 1, but it has 2 more. So here's why I wrote it as a root. So yes, this needs a square root of 3, but it needs 2 of them. It needs 2 of them, so it can be a square root to the third power. So notice what a square root squared is just the inside root. So this gets a 3x plus 1 outright, no roots involved. Okay, that's what the left-hand side needs. What does the right-hand side need? Okay, so it has a 2, has that. So the only thing that it doesn't have is a square root 2x minus 5. So this is all in the name of getting a common denominator. And now when I'm doing this, I'm writing quick and dirty math. What I'm physically doing is I'm multiplying the left-hand side by 2 over 2, and 3x plus 1 over 3x plus 1. That sort of concept. But I'm assuming that you know how to get a common denominator, right? So that's physically what I'm doing. I'm just doing the quick and dirty version so I know what to write down. All right, so what will this yield? What will this yield? This will yield a 2, and so this is going to 6x plus 2. And then this goes away, turning this into a parentheses of just a regular 2x minus 5. And so this would be negative 6x plus 15 all over a bunch of garbage on this bottom. So this is what? A 2. It has a square root of a 2x minus 5. And it has a 3x plus 1 to the 3 over 2. Simplification. This is going to be 2 square root 2x minus 5, 3x plus 1, the 3 over 2, all underneath 17. And that would be pretty much the end of the road. That's what it's going to look like. And again, I'm not asking you to do all of that. However, as I was saying, because your answer looks like this, be prepared to do this work if you are forced into a multiple choice question, or if you are forced to simplify to make it look differently. So as I said, the stuff written in red is correct. Didn't make any mistakes. But the answer looks far from what we have. I'll just kind of put that on the side here so you can kind of take a look at that. Okay, I'll rewrite this first one here real quick. So this is f. I'm not taking any derivatives yet. And then, so this is going to be to the 1/3 power. So the 1/3 power. So let's go ahead and take a derivative. So a big chain rule. So this is going to be 1/3. Leave the inside alone. The negative 2/3. And then times, and then when I do this chain rule, you have to make it into a quantity. So it's not individually, like if I see this, if I see a chain rule and it's just, okay, I'm doing the chain rule and this is 6x squared minus 10x plus 1, this is incorrect. This is incorrect. All right, because when you do the chain rule, the derivative is its own entity. So you have to kind of think of it as a polynomial. So there isn't any cleanup process. This is a pretty splendid answer right here. But again, kind of going down the rabbit hole of what an answer would look like. So this would be a 3 on bottom. This would be a 2x to the third minus 5x squared plus x on bottom to the 2/3. And then the numerator would be the 6x squared minus 10x plus 1. Pretty simple process there. Okay, what's the derivative of that? So let's rewrite this. F of x. F of x. I got a square root on the numerator, so that's the x squared plus 1 in the numerator. And then I have a x in the denominator, so that's to the negative 1. So again, this is going to involve the product rule while simultaneously using the chain rule. So the derivative of the u, the first bit of this, is going to be 1/2 x squared minus 1 to the negative 1/2 times 2x. All right, so that's the u prime. So don't forget that I had to take the derivative of the inside as part of that overall derivative. So that's the u prime. And then v is just the x to the negative 1. So that's u prime v plus v prime, v being the x to the negative 1. So that'd be negative 1 x to the negative 2. That's the v prime u, which is just x squared plus 1 to the 1/2. Cleanup process. Okay, so what I'm looking at is this 1/2, this 2x, and this x to the negative 1. And I see a bunch of cancellations. For instance, this division of 2 will eliminate this 2. But this is a division of x right here. This is division of x. So I get to eliminate that singular x. So this will just leave us with x minus 1 to the negative 1/2. And then this will be minus x to the negative 2x squared minus 1 to the 1/2. And pretty decent with that answer. Again, let's go down this rabbit hole of cleaning up things. This one's going to be kind of involved. Because again, we're dealing with denominators and roots and denominators and things like that. Okay, so this first bit has a square root of x squared minus 1. The second bit has a denominator of x squared, and this is going to be the square root of x squared minus 1. So again, the idea behind this cleaning up is to get a common denominator. So this left-hand side will need an x squared. Put it on the numerator. We'll need an x squared. And this right-hand denominator needs a square root of x squared minus 1. So ultimately, this denominator is going to be x squared square root x squared minus 1. Now, what repercussions are created because of that? Well, I see a square root times a square root, so that square root goes away. I see a negative coming onto the inside of this, so that in essence leaves us with x squared minus x squared plus 1. So this ultimately, see the x squareds subtract each other, is an x squared square root x squared minus 1 all underneath 1. That would be the answer that is the cleanest. . Now, last but not least, number 9. X. So I have a top square root, so that's the x minus 1. It's a square root on the numerator. Then I have a third root in the denominator, and that's going to be x plus 1 in the denominator. So that's a negative 1/3. So chain rule while simultaneously doing the product rule. U prime, so that's the x minus 1. So that's going to be 1/2 x minus 1 to the negative 1/2. Chain rule would be times 1. Okay, so leave the second piece alone. All right, so that's u prime v plus v prime. So this is the to the negative 1/3 power portion. So this is negative 1/3 x plus 1 to the negative 4/3. Again, times 1 with the chain rule, but again, have that there. So times 1. So that's v prime u. So I need to keep the original u. There is no cleanup process. That's pretty decent right here. But again, let's go down the rabbit hole because eventually you are going to have to be able to do this. I mean, you can't just survive with negative fractional exponents for the rest of your life. You have to know how to convert this stuff and do some arithmetic with it. All right, so again, the easiest process is to just put things where they're supposed to be. So the 1/2, that means a 2 on bottom. I have a square root of x plus 1 on, x minus 1 on bottom. And I have a third root of a x plus 1 on bottom. Okay, so that's what the first part has. The next one is not a plus, but it's rather a minus. It has a 3 on bottom. It has an x plus 1. Okay, again, I'll write this as a root. So this is a third root of x plus 1 to the 4th power. And then I have a square root of x minus 1 on top. Just figure out what each side needs. So for instance, this left-hand side needs a 3. And it also needs 3 more of the x plus 1s. It needs 3 more of these x plus 1s. So again, if I have a third root of x plus 1 and I need 3 more of those, I'm eliminating the root. So what this needs is just a quantity of x plus 1. And so that will leave this denominator. If I add 3 more of those, that would be a x plus 1, where there's already there, and that would leave 4 of them all together, so that's to the 4/3. Okay, so that's what the left-hand side needs. It needs a 3 and 3 more of those. What does the right-hand side need? Well, it needs a 2. It needs a 2. It needs a root of x minus 1. So again, there's going to be that. That's going to turn into a parenthesis. All right, so what is this denominator? So if the left-hand side got a 3 and the right-hand side got, the denominator is 6, square root x minus 1, and x plus 1 to the 4/3. Now, what's left with the chaos on the top? So this is a 3x plus 3 multiplied in. This negative is going to be up on that 2. And again, this turns into a parentheses without the root. So this is going to be a negative 2x plus 2. So this is going to be what? X plus 5. X plus 5 all over everything else. There it is.